Hi, in this video we are going to learn about a new thing which is pointers. It doesn't seem obvious right away why this is connected to our unit on input and output, but what we're going to see is that pointers are needed to actually use the input functions that we'll learn about next. So it's a difficult topic. Pointers are notoriously one of those things in C or C++ programming that is really easy to shoot yourself in the foot with and get kind of confused. But we are going to try to take it simple and just use pointers for the things that we need to use them for. And you'll see that it actually gives us a lot of power over what we can do with our programs. So let's think about variables for a moment. If you remember from a few weeks ago when we introduced the idea of variables, we said that every variable has a name and a type and a value. But then we've also seen that variables have one additional thing, which is scope, which is like which curly braces block of code does that variable occur in. And now what we're going to learn is that in addition to all these things, a variable also has to have an address in memory. Right? So when we declare a variable with something like int x, well, the compiler has to know about a number of things in order to make that work. So if we have something like int x equals 7 in our program, then, okay, the name is x, the type is int, the value for right now is 7, and the scope is whatever block it appears in. Maybe it's just the whole scope of main. But the running program has to actually store this value of 7 somewhere. And the place where that gets stored, that has a location inside your computer's RAM. That's called the address of that variable in memory. And so what pointers are is a way of accessing this address for any given variable. And so in order to get the address, what do? Is we just use the address operator, of course, but it's one that you haven't seen before. So if I have like int myvar equals 23, then I can say address of myvar, and that gives the address of wherever that's stored in memory. So it's not going to give the value of 23, it's going to give the memory location where that value is stored. And it's not that useful necessarily like to have this program as we have here, because it's just getting the address and doing nothing with it. But we can actually assign this to another variable, and the type of that variable is going to be int star. So what's happening here is that we actually have two variables going on. We have one which is myvar, and that's just an int like you are used to. But then we have this second variable here now called ptr. That's just a common name for a pointer variable. We could call it anything. This holds the address of the myvar variable. So wherever that myvar variable is stored in memory, this pointer is going to hold the address of that. And we can then do things with it, which we'll see in a moment. But it's important to know that the address of myvar doesn't change, even if the value of it does change, right? So if we changed to have another line and said, like, if we had another line down here that says like myvar equals 15, then the pointer is still holding an address to that variable. Now the value has changed, but the location in memory hasn't. Okay, so that's not that tells us how we can get the address, but why would we want to get the address? Well, the reason why is because we can actually use the address, use the pointer, in order to modify the original variable. So we can access the value. So if I did something like printf %d myvar, that prints 15. And just a small comment, in the previous video we told you to use %i for printing ints, and %i does work, but %d is going to be give us some more properties with the input functions that are important, so we're going to try to switch everything to say, hey, let's use %d. So %d is used for printing ints, and that's what that looks like. But we can also print directly using the same format string. We can print that value by what's called dereferencing the pointer. And so this is going to print whatever my var is, which is in this case also 15. Okay, so what happened in this second example is that this star here, that's called the dereference operator. And when we have star and then the name of a pointer variable, this dereferences it. Dereferences. So this gets back to the original value of what that pointer points to. So this is where we can use dereference to access the original value. And we can additionally, besides that, we can also use dereference to actually modify the original value. So I can also say something like star ptr equals 2000. And now if I do that, I have changed what? I haven't changed the pointer because the PTR is still pointing to the same place that it was. It's still pointing to the location where the myvar variable is. But this dereference says, don't change pointer, change the thing that PTR points to. So the thing that it points to is this variable, and now myvar is 2000. So we've actually changed the original variable by using this pointer change. Okay, so this is also called dereferencing, but you can have dereferencing both to get the value like here, and you can have dereferencing to do an assignment or to change the value like we do right here. And so sometimes when we're thinking about programs with pointers, we might actually start to draw some diagrams because it can be easier to think about that. So in this case, there's two variables. One is called myvar, so we can say myvar, and that has a value which is 23 originally. And there's also this second variable called ptr, and what's the value of this pointer? Well, the value of this pointer is just that it's pointing to myvar. So we can draw that as a big dot and then an arrow pointing to this other box. And so that reminds us that PTR doesn't really hold its own value. It holds a reference or a pointer to a different one. So then as we go through this program, when myvar changes to 15, what's happening is we're changing the value of myvar to 15. But that is also going to affect when we dereference PTR will also now become 15 because it points to this original value. And similarly down here, when we say star PTR equals 2000, that's saying the star says follow the arrow and then change what's there. So that actually changes the value of myvar by changing the value of star PTR. So a pointer doesn't really have its own value, it just points to a different value. Now the last thing I want to talk about here before we look at a real example is why would we ever want to do this? So this is some kind of powerful thing, seems maybe like it can be confusing. But the reason why we would want to use pointers is usually to allow a function to change the value of a variable. And so that's going to be the most useful thing that we see is that we use pointers when we're giving information to a function, then we want the function to change that value. So for example, if I want to get a pizza delivered to my house, because pizzas are delicious and I want to eat one, what do? Well, I have some interaction with the pizza place. I don't give my house to the pizza company. I don't like take my house somehow and put it on a truck and deliver that to the pizza shop. That would accomplish maybe getting a pizza into my house, but it seems like rather a wasteful job and wouldn't be exactly what I have in mind. What do I do instead? I call the pizza place and I give them my address and ask them to bring the pizza to me. So by having addresses, that allows us to do something like in programming, we'll do this with function calls, but it allows us to request, hey, please change this thing. Here's where it is. Go there and change it. And so we'll see examples of that when we talk about scanf in the next little section. But let me look at an example here that uses pointers. So here's the example. I will run it for you. It's not a very exciting example, but there's two variables, and we asked which one do you want to change. So, okay, I want to change b, and do I want to double it or subtract 1? Okay, I'll subtract 1. And so at the end, a is 10 and b is 19. Now, how can we write this? What we're thinking about with pointers is how can we write this kind of a program? Right now, the way that it's written is it works, but it has some problems. Okay, so it works, but it's not maybe the simplest or most efficient way of writing this program. So what does it do is it declares the variables at the beginning, then asks what do you want to change, and then depending on whether you type A or not, then it asks you, do you want to double or subtract 1, then gets that second choice and has an if-else statement to either double or subtract 1. But what you should notice here is that there's a lot of repeated code and the logic is a little bit maybe more convoluted than it needs to be. So how can we simplify this? One thing that you should see right away is that the first two lines of the if-else here are the same. And so there's no reason why we can't just do that actually outside of the if-else statement. And this is a common thing that you will notice in your own programming, like for the previous lab was a good example of this, where if you find yourself doing the same exact thing in an if-else statement, the more that you can bring out of that if-else statement, the simpler and easier to debug your program will be. So that's an easy fix that we can make. But now beyond that, we can't really do anything else better to simplify this code because we have to either change A or we have to change B. So there's kind of 4 things that can happen, and it has to be with this nested if-else kind of situation. But if we use pointers, that allows us to have the same code, which is going to change either A or B, depending on what the pointer points to. So what we can do with pointers, and again, this isn't the most enticing example, but we can have a pointer type, which is A or B, a pointer to A or B, and then if the var name equals A, then I'll set A or B to the address of variable A. So again, A or B is a pointer, and when I use this ampersand, that gives the address of operator, so that stores the address of A's variable in this pointer variable. Otherwise, I can say A or B equals the address of B. And now, instead of having to have a nested if-else statement, I can just have a second if-else statement to either double or subtract 1, depending, and it'll change either A or B depending on that first if statement. So what's going to change here is that instead of dealing with the variable A specifically or the variable B specifically, what is it going to look like? Think for a second. Well, we know we want to use the pointer, but we can't use the pointer directly. We don't want to change what the pointer is doing at this point. We want to change the thing that the pointer points to. So we're going to need to dereference the pointer, star A or B. And I thought that my clever thing here would be able to do this all in one. I think maybe this will work. No. There it is. Okay, so I used the clever vim command to do those changes all at once, but all we did was we changed where we previously were referring to a specific variable A or alternately the specific variable B. Now we can refer to this dereferenced pointer, which is going to update either one. So in this particular example, okay, we saved one if-else case, so it's not the most best change, but what you can see here is that we've kind of decoupled and simplified the program. If we wanted to add another action like adding 3, well, that could just be another condition down here. We wouldn't have to change whether we're changing the variable A or B because we've kind of dealt with those things separately now. So it gives a lot more flexibility and power to the programs that we write. And I'm a little bit worried to try to compile this, but I will. We did it. Seems to work. If I say I want to change variable A and I want to double it, then A gets doubled to 20. But if I want to change variable b and double it, then b becomes 40. So because we use this pointer that I called a or b, that means that the changes that happen down here are going to affect either one of those variables depending on what it points to. So that's a small example of where pointers can be useful. Like I said, the most time when they're going to be useful for us for now is when we call functions. Last thing to mention is that you already have been using pointers a little bit. And this is outlined in the notes, of course, but you've been using pointers already in two situations. The first, and this is also towards our goal of not needing to use IC210.h. The first one is the type stream. So when you have something like stream fin equals fopen my file for reading, well, the stream is not actually a built-in C type. The real type there is file star. So anytime you're using stream, you can actually just use file star. It's a pointer to a file object. And what's in that file object actually doesn't matter to us as programmers, but the way that C works is that it treats every stream, including standard in and standard out, are pointers to these file objects. Now, why do they need to be pointers? If you think about it, when you call a read or a write function, it needs to actually update that underlying file by like reading some more things from it and changing the position where it's reading from. And so because when you call those functions, you have to change the underlying thing, that's why it kind of makes sense for it to be a pointer. And the second example, which is a little bit more subtle, is when we're using the C string type, which is the other type that's kind of defined in the IC210.h file. So if we have this C string name, what is actually the type of this when we're calling functions? This is a char star. Why does that make sense? Okay, so char star means a pointer to a character, and as we'll see, this is actually an array, which we'll learn about in a couple weeks. But when we call functions, it passes a pointer to this string, which is actually a list of characters. That's why you get actually a pointer to just the first one. And again, why is that important is because when we're doing things like with manipulating strings, concatenating strings, and so forth, you want to actually change the original string, so you have to pass a pointer to it. And also, the other reason is kind of like similar to the house example, because strings can get very big. It's wasteful to have to copy a string every time you call a function, and so that's another reason why strings are treated as pointers to characters. So you can still use IC210.h for now, but this is just to let you know that we've actually already been using pointers. It's not that big of a deal, and the reason why we do it is usually because we want to call a function and allow that function to change things that are in our original program. So that's an overview of pointers. We talked about the pointer address operator, the dereference operator, how to declare variables which are pointers, and a little bit of what they're useful for. And the next section we'll talk even more about specifically how do we use pointers when we're reading things with scanf. And that's it for now.